Hi, it's project series time. This is part one in hopefully a project series where I develop a new product I'm going to call, there's that bloody beep again, I still can't find it. I'm going to call, it annoys everyone. Anyway, this is a project I'm going to call the µTimer, as in, you know, µ, the micro symbol, the µTimer, and I'm going to develop a lab Benchtop, similar to this Brannon one here, but this is, you know, there's quite a few on the market that have like a similar sort of desktop form factor, and I've always wanted one of these. This one's okay, you've seen me use it. It's got some external inputs here, but they're not very versatile. But anyway, it's just a basic timer. It's just got, you know, start, stop, and you can just override with external inputs here, useful for you know, like timing projects and things like timing processes and things like that, where you might want to like automatically you know, start and stop, trigger it, and so you don't have to be there to actually watch it. So, but this is, you know, very limited functionality. But these sort of benchtop form factors very common in sort of the educational space, the science lab space, that kind of thing. So yeah, I was going to develop something similar. So the design is basically all centered around the choice of the LCD, really, because, you know, the form factor can come later. It really needs a good LCD. Now, so I originally thought that I'd get like a custom made 7-segment display, and I'll link in a video here if you haven't seen it, where I develop a custom LCD and I show you, you know, how relatively easy that is, and relatively inexpensive as well, depending on where you go. So a custom LCD, and I thought, you know, I want bigger digits so that you can like see it from like across the lab. So custom 7-segment displays like this have like, you know, you can get like really good contrast on them. That's the best in terms of contrast, but it just limits the functionality. And I thought, well, I don't want this to be a jack of all trades, masters of none. I thought that not only would I have a bigger display, but I'd make it full dot matrix as well, just for some versatility. So you can change the size of the font if you want. You can have like multiple timers going and things like that. So you can't really get that flexibility with a like a custom 7-segment LCD. You're just fixed. So yeah, I thought I'd get a low power, because it's got to be battery powered from like a couple of AA batteries. Haven't decided on the power source yet, but so we need like, you know, sub 1 milliamp kind of consumption. So I was looking around at LCDs and I figured that a 4-inch diagonal one like this this is actually I think 4.1 inches visible area or something like that. But yeah, basically at least a 4-inch display would give like nice big digits that you could see across the lab. And of course it's got to have good contrast as well. It's got to be low power, so it's battery powered, so that you could have like a clock on this thing during the day when, for example, when you're not using it as a lab timer. So I was looking around at 4-inch LCDs and I found this East Rising one. They're at they've even put their website on there, buydisplay.com. And so I got this sample. This is an ERC 19264-1, and this is about $9 one off, and the price drops in volume, of course. Now, it does include a backlight on here, but this is what's called a Transflective display, and I think I've done a tutorial video on LCDs and the different types. So Transflective means is that it combines the best of a reflective, this is a 100% reflective LCD, like there's no you don't need a backlight, it doesn't have the ability to have a backlight, it's 100% reflective backing on it. So that's called a reflective LCD, and this one is also reflective, but it's transflective in that it will also allow a backlight through, and this one does come with the like a nice white backlight on it, where it allows the light to come through. But I don't really need the backlight, but I guess I could put a backlight button on it, so you know, if you want to temporarily turn the backlight on, you can, but otherwise it's going to chew too much battery power. So ideally I wanted a fully reflective LCD display, but I couldn't readily find one in 4 inches. So anyway, I got this one and I thought we'd try it out. It's 196 by 64 in, like, as I said, like over 4 inches visible diameter. And it's got chip on glass, COG. You can see down there, because that's a glass backing and the chips mounted directly on the glass in there. That's the driver driver chip for it. We've got a 36-way flat flex here with 0.5. I hate the 0.5 millimeter pitch on it. And this one actually comes with an optional font chip, which stores all the fonts in there so that you don't have to install the fonts in your, compile the fonts that you're going to use for all your text inside your microcontroller. And that just means that you can use a smaller, simpler, cheaper microcontroller, and then you can simply read the fonts from here and then transfer them directly into the chip as you need them. So yeah, it just frees up memory space in the microcontroller that would otherwise be taken up with fonts. So anyway, that's handy. So if you do know of a 4-inch fully reflective LCD instead of the Transflective one like this is a FSTN one, and I'll link in all the data sheets for all these things down below. So anyway, for you film aficionados, we have the film on it. Oh, look at there. There we go. Oh, thing of beauty. Joy forever. So basically, this video is just testing out what I think about the contrast of this LCD and, you know, how it looks. So I wanted to get this up and running very quickly, so I ordered the demo board as well. This is actually quite cheap. It's an 8051 demo board specifically for this LCD. Well, they will match it to the LCD you buy. They've got, like, you know, tons of different LCDs and they will match it. So this is the driver board for it, and it's got like example programs built in, so we should be able to get this thing talking straight away. And then it comes with an interface board like this, and you can see that they've already pre-programmed on the 36-way flat flex connector 0.5-inch pinch. So these are different pitches. We've got the 0.5 we're using here, we've got 0.6, 0.62, 0.65, 0.7, 0.8, 0.9, so 1, etc. So we've got all the different pin pitches here. So this is a very handy board, and you'll notice that you can also tie any of the pins. I think this is like the positive side. They should label it a bit better, but anyway, like you can tie each individual pin down to ground up here. So they've installed like some caps up here, so you can put capacitors down to ground. They would be for the internal contrast boost converters, for example, the bias capacitors, the bias pins on the LCD. So you have to put those, you know, in various configurations. Yeah, they've got a capacitor across 2 pins there, or they've got others going down to ground like this, and they've strapped these pins here. So I haven't gone through the exact pin out of this thing. They're only using some of the pins here. I think I specified an SPI interface because this LCD is capable of SPI serial interface. I think it might do I2C as well as 4-bit and 8-bit parallel interfaces as well. So it's very flexible, but I think it might be working serial, but haven't 100% confirmed that. Anyway, let's plug it in and see if we can get this thing working straight out of the box. All right, so we put that in there. We get that shut like that, and let's power this thing up. All right, I've plugged in the USB here, haven't plugged in the backlight yet. Let's just see, because I really care about what it can do without the backlight. So let's power on. Hey, there we go. EastRisingByDisplay.com, and boom, straight off the bat, it is giving us all our outputs. Look, and it's changing the fonts as well. So it'd be, I don't know if it's reading from that actual font chip on there or whether or not it's just got them programmed in. But of course, when we're like having big digits, I might have to do like custom fonts. So not sure if I'd use the font chip anyway, but might as well include it in the design, I guess. Look, that's quite a large font, but that's still not as big as we want. But yeah, there you go. So cool bananas. So right out of the box, they've sent me this demo board, and there you go. The Dash series, they've got their Panda. There you go. And it's got a stop button on it too, so we can, yes, we can freeze that. So there you go. It works out of the box. It's not a bad viewing angle. So when you order LCDs, either custom or off the shelf like this one, they will have what's called a bias angle or a view position or something like that. The terminology can interchange, but we'll just stick with bias angle. And what that means is that you can get them in 2 types, either 6 o'clock or 12 o'clock. And it refers to either up or down on a clock, basically. And this one's a 6 o'clock one if you look at the data sheet. And what that means is that this is the bottom of the LCD. So it's designed to be viewed from a lower angle like that. So, you know, if your eyes are over here, you're looking up at the screen. So that's called a 6 o'clock bias or viewing angle like that. And if you get a 12 o'clock one, it's actually over here like this. So you're looking down on the LCD. So if you've got a product like this, if you're viewing it from like a long way across the lab and if you've got it sitting on a bench, you'd be viewing it in from looking up at the LCD. So you want this 6 o'clock one that we've got here. But if you had something that was flat like this and you're looking down on it like this, then you would want the 12 o'clock bias angle like that. And on top of the bias angle, which say it's at 6 o'clock like this from the bottom, you will then have the viewing angle. Please excuse the crudity of the model, didn't have time to build a scale or to paint it. You will have the viewing angle, which is then plus minus a certain number of degrees. Say you've got a 60-degree viewing angle, then it would be plus minus 30 degrees from that bias angle. So if it's 12 o'clock, then you'll have a viewing angle like that from the positive side. But this is the 6 o'clock one, and it'll have a viewing angle. But anyway, but you can see this actually has quite a large viewing angle. It's hard to capture this on camera, but anyway, yeah, you probably want a 6 o'clock viewing angle for a product that's shaped like this. You certainly wouldn't want 12 o'clock looking down like that. That'd be wrong, especially when you've got the tilted angle already. It's hard to show LCDs on through the camera, but that is direct. And if I tilt it like that at the lower 6 o'clock angle, you can see, yeah, that's probably a better optimal contrast, but there's not much in it. It's pretty darn good. So I think this LCD is definitely a contender. I really like it. Oh, what's happened there? What's happened up the top there? Can you see that? Look, there's some bleeding or something. What's going on there? That wasn't there at the start, right? I'll have to review my footage. I'm sure that wasn't there at the start. What the heck? They're individual pixels. There's nothing physical there. Anyway, this also has some contrast buttons. Yeah, I can adjust the contrast. There you go. So I can take the contrast right down so there's nothing on the display and bring it up. There you go. So it was set. That's pretty optimal. That is quite dark. I'm really quite happy with that. As I said, it won't be as good as a custom 7-segment display. You can really, a proper reflective one, but geez, yeah, that's not too shabby at all. Check it out. I just went to record the Amp Hour podcast, came back, and I noticed that it's all gone. It had completely gone, but it's actually now slowly starting to come back. Look at the pixels up there. And if I sort of, maybe, is it a static thing? If I rub my feet, something's going on. It was completely gone before, but you can see that now it's starting to come back. That could be some sort of static build-up on some unused pixels around the edge or something. Anyway, we'll leave that as a curious oddity for now. Might have to come back to that later. And I thought I'd measure the battery current, but I've just come a gutser. I tried to pull the pin out here, which is the positive power pin, but the actual clip didn't come out and I pulled the wire out. Oops. One of the annoying things is that they've actually offset. They haven't put this right over to pin 1 over here. They've soldered it offset onto pin 5 and 6 over here, and they've done the same thing over to here, but so pin 5 becomes pin 1 here. So when looking at the data sheet, I've now got to add 5 onto it. Oh, why? Yeah, that bleeding there at the top, that is just some excess liquid crystals outside of the main dot matrix display area. And yes, it is my static chargers actually turning those on. So yeah, it's interesting though. And you can see they're outside of the area, because if I turn the contrast right up, yeah, you see those at the top there. So just some extra liquidy crystals. Bonus. Well, Dole, I've got the correct power pin now, which is pin 19 down here, and which is offset by 4, because I got the data sheets goofed up because I have another display here, which is completely different, which I might show you later. Anyway, you can see, yes, that it is actually working with no power pin, because I've done a video on that. And I'll link that in. So, but let me now plug in the power pin, which will override it being driven elsewhere. There we go, making contact, 280. Well, and you can see it just reset. It dropped down to, what, 180? As you can see, it's put in more. As it's put in more data on the screen, it's going to, increase. And it'll increase as it puts more on there. But that's, the datasheet value is 800 microamps. But, it looks 650. Okay, so yes, if all dots are on, then yeah, it could take 800. And really, I'm after a low power display. So drawing like, say, 250 microamps displaying, say, a clock or a timer as it's ticking over or something like that, that's actually reasonably significant. So it would have been nice if the LCD had less than that. So, interestingly, in the datasheet, have a look here, it has a high power and low power pin. So I wonder what's doing there. So I wanted to try out this other LCD that I got, which supposedly has, according to the datasheet, lower power consumption. And it's the same part number, but it's a -6 instead of the -1. And oopsie, turns out has an entirely different chipset in it. That means that the firmware that's programmed into the demo board is not going to be able to, almost certainly not going to be able to talk to this. And I looked at the website. Website's absolutely fantastic. You can download the schematics for the demo board. You can download the programming software for it and all sorts of things. They've got all these documents that tell you how to install the programming software and do all sorts of things, which is great if you want to they tell you how to download your own fonts and stuff like that and images and things like that. But what they don't tell you is how to actually drive another different LCD. So essentially it looks like you've got to buy another demo board which they've pre-programmed and pre-set up and wired for this particular board. And I didn't know that. When I got it, I thought, oh yeah, I'll be able to, fairly easily maybe change some jumpers or something, but it doesn't look like that's the case. Anyway, so what I thought, I did actually get the connector for it, because this is a different, it's not as many pins, doesn't have the font chip built in, but that doesn't matter. So what I thought I'd do is actually hook up this LCD to this board so that then I can get, nice pin headers like this, and then I can get an Arduino or something to actually program this. Now maybe I can vibe code, AI code, just to get it running very quickly and see if I can just get something on this screen to be able to, actually demonstrate and see how good the contrast is, because this is lower cost, lower power, but same resolution and same size. So yeah, it's definitely worth trying out. Now, I could just order the demo board, of course, and it'll get here, but it's another week or something. So I thought I'd at least try this now. And the demo board's cheap. It's only like $22, but you've got to pay postage on top of that. So, it's not really worth an hour of my time just dicking around here, but I do kind of want to sort of get this running now. So I thought I'd at least spend a little bit of time actually just trying to, hook this up, get it, figure out which pins I need to strap and everything else, what caps I need to put in, etc. And then just try and program it with an Arduino and just get some AI code to just pump out anything. I don't care what it is, just want something on the screen. Now, this is 0.5 pin pitch, and sometimes you win, because look at this. Look at this. I can't fit it this way, like this, but I can fit it in this direction, like this, and it perfectly fits with one pin. This last pin, which looks like it's soldered in, is not. It's got some solder on it, but there's no actual pin there. So I can put it in this direction, and beautiful. Yeah, so pin 1 will be over here, so I've got to flip the numbers and everything, but everything's routed out. So yes, that's a win. So I'm going to solder that on. So let's solder this on. I'll just put down some flux. There we go. Bobby Dazzler. And we'll place this on here. And because these are really hard to hold, keep holding down while you actually drag solder, I'm just going to hold it in place with some capped on tape. It's not going to sit flat, so probably have to put some little bit of downward pressure on it like that. But apart from that, we should be right. So we'll just use my weld tip. Oh, whoa, accidentally, whoa. There we go. come my guts are a bit there. Can fix that up later with some wick. That's pretty poor effort. Yeah, couldn't get that one in there. Might need a small, yeah, I need a smaller tip to get in there. Unfortunately, I made an accidental contact when I first did that. So anyway, let's wick some solder away from there. Now, unfortunately, my small tip desperately needs to be tinned, but I can't find my I can't find my tinning stuff. It was here my tin of tinning stuff was here the other day, I swear. There we go. That's the ticket. Yeah, get rid of that ball. All right, there we have it. It's not pretty, but that is soldered. So, oh, it just dawned on me that these 4 pins over here, the foremost outer ones, aren't actually routed out to any of these down here. That's why this one over here, they started this 4 pin. This is why they started at 5 on the 5th pin, because the 5th pin is the first one that's actually routed out. That's why it's C5 down here, because it's pin 5. So pins 1 to 4 aren't actually routed out there. I don't know why. I'll put up the schematic for this board here. I'll overlay it, and you can see that they don't route out those pins, which is, I don't know why. There's enough room on the board. Just make the board slightly bigger if you need more routing room or something, because there is nothing on the other side. This is a single-sided board. But anyway, luckily, they do actually route out down to here, so I can actually connect physically down to here. So that's good. But yeah, if I just want to strap things easily, it's just not as nice on those 4 pins. But those 4, I believe pin 4 is the power pin, and some of the others are, yeah, like a drive voltage or something. And my winning continues. I don't have the right angled ones like this. And okay, so what I'll do is I'll just put it in there on a flat plate, and then I will stick this down so that just it holds them aligned, and that will give me enough room under there to solder each individual pin. I will spare you the boring details. So what I've got to do now is reprogram this thing, and they do actually provide the software and the example file. So I've got to compile, got to install the programming software for this chip, which is the STC25 LCD and they provide. So I got the programming software for that, and the compiler as well. They provide the source code for it, so they give you step-by-step instructions on how to do this, and then download it, hopefully, via the USB connector here, and reprogram this Flash 8051-ish microcontroller. But then I've got to figure out how all this programming configuration matrix, obviously they've programmed these in for the specific pin header that we had for the display that we've just played with, but it's going to be different for this new LCD, which is a totally different pin out and everything. Now, because this is already, well, I don't know, I'd have to check the source code for the old one and then figure out which pins are the serial outputs, etc. But basically, anyway, we've got the schematic for this new LCD. This is if I'm using the full-line SPI reference. This is the display. It uses the ST7525 chipset. And it just, yeah, this is how you hook it up to the MCU here. So all I've got to do is add a 1 mic cap there, a 1 mic cap between these 2 pins here for the bias voltage. This chip is actually easier to drive than the previous one. Like you need a lot more external caps than this one. So this one's actually more better. It's got built-in capacitors which generate the various bias voltages and things. But still need a couple of external caps there. Just the bypass in there, tie a couple of pins here which select the mode. I won't go through all the complete data sheet, but this selects the SPI mode, and then chip select, and then data instruction select pin on A0 there. And so we only have to, in theory, hook up 2, 4, 5 pins to here, plus the 3-volt power and ground. And then if we hook them up to the right pins on this via this selection matrix, so I've just got a wire bundle here, so I'll be using these pins over here. I'll put some of those caps I'll just tie on here or whatever, and I've got all those pins coming out to this one side. So I think at the moment it's connected to the power pin, but you can restrap that, and and I'm feeding in power to different pins now. So, but hopefully, if I decode all this, get it correct, and I install the software to program this thing, I should, in theory, be able to use this demo board to reprogram this. It's just when you order it from the factory to match your LCD, they've already programmed it with the correct software. They've already done the correct pins. They've already even done the wiring harness for you, and they've put it over, and then they've configured this board correctly with all the pins. So they've done all the hard work for you. So it's trust me, it's worth paying that $22 US to actually, if you're going to get one of these displays from them, and for $22 you get it all like pre-configured and working out of the box. Yeah, unfortunately I don't have that for this new one. Anyway, be an interesting exercise, I guess. And just as an aside, here is the ST7525 interface here, and you can see this is the chip on glass, the COG chip that's actually on the glass, and how it drives all the commons here, and then all the segments going down here like this. It's just an assembly note, gold bump is face up, and here's all the pins. So it's actually got a lot of input pins, and they're all tied together, and you can see this is the glass, and this is the FPC, this is the flat flex interface, the pins for the flat flex, and then the system, it shows how you just put the the one cap we saw across the V0 and XV0 pins there, and yeah, there's not much else to it, but they do supply quite a lot of documentation like this. You can't fault them. It's very thorough. Actually, first cab off the rank, I'll show you here. It shows, look, serial data input to the LCD, or output from the microcontroller. That is pin P11 there. And if you enter the matrix here, you'll see that P11 here, that's this row going right across there, has no solder jumpers on it whatsoever. So the good thing is that I can just attach one of those. So I can go, okay, which pin's not being used? Actually, they're all being used. 1, 2, 3, 4, so like 6. So all these numbers here correspond with the numbers on here, and they all go vertically. So it's just an XY matrix that needs to... Anyway, I'll do that as a reference, just in case I have to go back. Reference shot, just in case I have to go back and drive the old LCD. But yeah, it looks like I'm going to have to reconfigure this. Although, but hey, look, pin 16 isn't used, 17 isn't used, 18 isn't used, 19 and 20 are used, so I've got 3 spare pins there, and if I put some extra pins in here, unfortunately it doesn't go all the way to 28, it only goes 21, 22, 23, 24. I'm not sure why they stopped the silk screen there. The traces seem to go to it. 24 seems to be going to 2 locations, actually. 24 seems to be bloody black solder mask. It's hard to see, but is that 20? Yeah, 24. Yeah, 24 does bugger off to there. Oh, yeah. Are they also going to the vertical columns as well? So, anyway, there are a few spare pins there I can use without touching the rest of this matrix, and just leave that intact if I need it. This is actually working out quite well. I've soldered in pins 16 and 17 up here like this, but then ones like P3.4 are already being used here, so that goes to pin 9. So it's already there. And 3.3 is already being used. That's pin 8. So, boom, I'm pin 8 there. And 3.5 is pin 10. Ah! Bobby Dazzler, look at that. I only had to use solder in 2 extra pins, which didn't upset the original programming at all. But I do have to reprogram this chip, but in theory, if it works, I can just swap between the 2 programs for which LCD I want to drive, and you've got to change the wiring harness as well, but, yeah, should work. Assuming I don't goose something up, we should be able to get this working fairly easily. And just so I don't screw this up, pin 60 over here is now pin 1. There you go. So that'll be 319. Right. So I shouldn't goof that up. VSS VDD, I'll check that goes over to here and I can do whatever. Between the 2 pins, that capacitor between the 2 pins, I can probably put a cap like between 2 of the pads here. Just a little pro tip, it's worth going to the effort to just do this so that you don't goof it up, because sooner or later you're going to come a gutser. If I left that at 60 and then I was just continually visually counting numbers, I would have just, totally come a gutser. Now I've got a 1 microfarad 0603 here, and unfortunately, I I have to use this pin pitch here, which doesn't quite fit. I've got to go between pins 2 and 3. It would have been good if it was 2 and 4 there. The other ones don't go to pin 60, unfortunately. Of course they don't. So I kind of have to be real careful there. Whoa, nah, it was touching pin 3, wasn't it? This is tricky. There you go. There you go. Oh, I think I might. Oh, is it shorted down there? I don't think so. I might get away with this. I could go for an 0402, but I just had an 0603. I don't know where my 0402 is. I had this one to hand. I'll use my LCR meter and see if I've actually got that. Right, well, I've got it hooked up and I've installed the software. It just installed. No problems whatsoever. The driver, I had it already installed. It was a CH340. You can see there, set up as COM5. No worries. And then this software, the amount of support, like if I expand these, they just go on and on and on and on. Like if I just go like this one down here, for example, just supports all these different versions. It's just insane, all these variants of this part. Anyway, this is the one we've got, the STC12LE5A60S2. I think I've got that right. So I've got the C file here. I got the source code for it. And it looks like they actually include the fonts in here. So they're not reading the font chip, but this one doesn't specifically have a font chip. So there you go. That's an 8x16 font, etc. Right? So that's all built in, which is fine and dandy. But I need to generate, like, do I have to go find myself an 8051 compiler that supports this? Doesn't make sense. This is just the programmer software. But I can't find the hex file. So without that, I'm up the creek without a paddle. Right, so at this stage, I have no real desire to go and try and find an 8051 compiler that supports this chip, and then, like, sure, you can compile it, but then have you got the right fuses and everything else, right? Whatever that micro needs, like, it would have been great if they just supplied the hex file, and I could just burn it in, but it doesn't seem to be on their website, so I'm going to have to contact them. Well, it turns out their service is very good. They replied to my email in like 15 minutes or something. Unfortunately, yeah, it looks like they don't supply the hex files. Thanks for your email. The demo board you purchased can't be matched with the ERC, the -6 version. I've got the -1 version, which is what we used before. Even if you reprogram the code, you need to buy a new demo board. I don't think that's correct. I was asking about the hex files, but they're basically saying, no, we're not going to give you the hex files. That's basically what it means, which is ridiculous because they give you the actual source code. You can download the actual source code for each individual demo board that's matched with each individual LCD. The full C source code. So why not just give everyone the hex file? I don't know. I guess they don't want the support requests from, you know, idiots like me trying to like reprogram the demo board because it's complicated to do, as you saw with that matrix and everything, and figure it all out. And so I can kind of understand why they don't want to give you the hex file. But they give you the source code just because, well, an example of how to actually drive the LCD. But yeah, they don't want you dicking around with that hardware board because it's too hard. So anyway, I was looking around for other examples for the ST7525. Thought I might be able to find some Arduino code or something like that. Couldn't really find anything. There was some code on Adafruit that worked with a 7565 or something. It's like a smaller graphics thing. I'm not sure if it's probably compatible enough that it would have worked. But anyway, back to buydisplay.com. I found that they actually have this exact one, which is SPI for Arduino. Here you can buy the module, and it comes with a board that just has a nice little, you know, SPI bus on it to hook up to the Arduino. And if you go down here, they have all the stuff. They have the data sheets, the controller data sheet. They've got an Arduino library, an example, but yeah, then you've got to like level convert because the Arduino is 5 volts. It expects 3.3. But down here, they've got a Raspberry Pi library and example. I've got a spare Raspberry Pi. Let's give that a whirl. But as it turns out, the Arduino library and example doesn't actually have as much info as the Raspberry Pi thing does here. So what you actually get inside the Raspberry Pi one is you get an interfacing document And that tells you how to interface the -4 one. Mine's the -6, but you know, it's the same chipset and the same resolution, so it should work, and tells you how to hook it up to the Raspberry Pi here. Beautiful. And if we go in here, we've got all the source code for this. They've got a make file for it. They've got a README text, which then development OS Raspbian for Raspberry Pi, BCM2833 is the library that it uses, and they've got the table of how to hook it up to the physical Raspberry Pi 3 here. Look at this. This is great. And there's a difference between the BCM, like the library, the actual chipset used, the pinout on the chipset and the pinout on the Raspberry Pi. So they tell you it's physical pin 22, whereas in the actual chip itself is pin 25. But yeah, this is great. And then they give you instructions on how to run this LCD demo test. So let's give it a whirl. Right, so I've got an old Raspberry Pi 3 Model B v1.2, and I've downloaded the latest Raspbian OS or whatever it is onto it, and I've got to install this BCM2835 C library from Mike M, whoever Mike M is. Thank you very much, Mike M. So I've done this. I've installed libcap, and then I've added the user, which is EEVblog, to kmem, whatever that is, and then I've done these things here. This thing is slow as a wet week, by the way. Terrible. Anyway, I've downloaded the compressed library for this thing. So now this should work, I think. Oh. No, cannot open, no such file or direct. Oh, I've got to put in the number 1.75. Okay. Yep. Oops. 75. Let's try that. There you go. So that's done that. It's in the download directory. Whatever. Geez, this is not easy, is it? Is it like this for all? Just like toggling a few I/O pins on a Raspberry Pi, or is it just because the LCD company's just decided, the programmer's just decided to use this particular library or whatever? Is that the deal? I don't know. I don't do coding on a Raspberry Pi. Oops, it doesn't like that, does it? Oh, get rid of that. Don't know why it added that at the end. There you go. Whoa. We're in. And it's configuring. Yeah. Okay, it's executing all that. Then I've got to make. So let's make. Extracting directory. Yeah, it's doing stuff. This is good. See, how would you figure out to do all this without like instructions like this? It's just crazy. And this is just so that I can compile the code and then run and toggle a few I/O pins. But hey, it's better than buying a new demo board, I guess. Sudo make check. There we go. Oh, yep, pass one. Yep, that sounds good. Sudo make install. This is crazy. I understand what it's doing, but there's no way I would have figured out this on my own. Absolutely no chance whatsoever. Yeah, okay, so it just mentions Raspberry Pi 2 to enable device tree support. Do I know that's only for Raspberry Pi 2? Real-time performance constraints? No. Interactions with other systems? In order for your library SPI to work, you may need to disable the SPI kernel module using this. Oh, well, I may have to do it. I don't know if it's going to bit bang the pins, or like the software's going to bit bang the pins, or whether or not it's going to use the hardware SPI or what. I'm not going to touch that now. I won't touch that unless it doesn't work. Unless I compile the code, run it, and then I can't see any data toggling on the pins. Then I'll know something's wrong. All right, I got the Raspberry Pi code here downloaded. I've got the text file, which tells me how to physically connect it. There it is there. And I've got to make it. So I've got to make the file. So I've opened the thing here, and I've just got to do make, because it should have the make configuration file. So make LCD test is up to date. Done. Okay. sudo./LCD test. I'm doing this all on the USB stick. It shouldn't matter. No, command not found. No, it didn't make it, did it? So there's the make file. So it should call GCC don't know what wall is, and it should compile the code using the BCM2835 library, which we installed previously, and it should generate the LCD test executable, but it's not. So, okay, apparently I can go make clean. If I make that again, okay, I've cleaned it. There we go. Right, I just had to clean it first. There you go, trap for young players. GCC wall, blah, blah, blah. It did it. Okay. I expected some sort of output from it, but I guess it's done. So now I can run it. Haven't actually connected up the LCD yet, but I can do that if once I get through this. sudo.lcd test. No. Woo! I got it running! There you go. It didn't like the USB stick for some reason. I'm not sure why. Yeah, everyone's screaming in the comments, whatever. But yes, it is now running. So therefore, there we go. It's doing LCD begin, LCD bitmap clear, display time. I don't know what the program does, but yeah, there you go. It's something. So I'll hook up the screen now and hopefully it should work. Should be getting... Those pins should be toggling. If I hook them up the right way and cross your fingers, tongue at the right angle, you should get something on the screen. Winner, winner, chicken dinner. You can probably barely see that, but there is a clock. There is a clock that is working. So we have a contrast issue, but we can fix that. So there you go. All that rigmarole I had to go through just to run this thing. I don't know if that's normal. I don't know. I've never written a program for a Raspberry Pi before, but we installed Mike's library or whatever it was, and then we did some sudo magic, and we built it with GCC, and it actually worked. So, yeah, that's amazing. And I didn't goof up the wiring and over here either. So, yeah, my soldering worked, and everything worked first go. I did not expect that to work first go. I thought Murphy would absolutely bite me on the ass there, but no, Murphy's sleeping and it's 7 p.m, damn it. I'm going home for dinner. Alright, so let's measure the current consumption. Oh, there you go. I disconnected the power pin and the contrast has changed because it's being powered by effectively a different voltage, a lower voltage, because it's going through the pins. It's going through the I/O. Whoa, there we go. It's jumping all over the place. Anyway, let's power that. And, oh, 600 microamps. Well, so much for that. It's set 180 microamps. I know, like, there's a lot of the contrast isn't set properly. That's a software setting, so a lot of the pixels are, like, partially on. But damn, it's supposed to be like 180 microamps. So now I've got to figure out where they're setting the contrast in here. And, well, it's got set LCD mapping control, set output voltage. Is that it? Char 16 by 16, 32 by 16. Is that the big clock display? Yeah, yes, it would be, because that's half the height of the 64 LCD. So that's the font that they're using. So just to get me started in this timer project, I can just use that 32 by 16 font. No worries. So if we go to the chipset datasheet, very comprehensive, of course. All LCD datasheets will have the, not necessarily, this is not the datasheet for the LCD module itself. You've got to go into the chipset datasheet usually to get this sort of stuff. And here's the instruction table here, and the instructions set contrast, boom, it's a 2-byte instruction set VOP voltage. There you go. So you put 1000, which is an 8. So in hex, because you'll be sending hex values, usually we'll see that in the code in a second. So that's an 8, so 8, 1, and then it sends that 8-bit value through to set the VOP voltage. So if we go into the source code here, we can see that there it is, OX81, set output voltage. it should have said contrast there, but you know, and then that's the value 154. So that's what that demo board would have been doing. Even with the other different chipset, it would have been setting a register value in there, and the buttons just would have incremented or decremented that register value for the contrast. You know, old school LCDs, they'll have a trim pod in there and you can adjust the DC voltage, but modern ones like this, it's all software programmable, and Bob's your uncle. So yeah, all I got to do is change that figure. Yeah, I don't have any ready buttons hooked up to it. So I'll just like experiment that, recompile it, takes seconds, and then run it again. It's no problem whatsoever. So I'll just, you know, fiddle with that value and see if I can get optimal contrast. And there we go. I set it to 100. I didn't know what the, you know, value was good, so I just changed it from 150 to 100, and that's not bad. That's not bad at all. That's, you know, reasonably close. So that's pretty good. Is that, oh, it's hard to tell. I can't really run the two side by side, unfortunately, because the cabling just doesn't allow me to do that. This is straight on. I'll see if I can get a screenshot from the previous one and try and do a comparison there. It's hard without the same information on the screen, but that's not too bad. Remember, this is a lower cost LCD. It's about, I think, about 40% less cost or something. But yeah, I'm not getting the power consumption. That is a problem. But anyway, that still looks pretty good. It's, you know, its angles are pretty great. So I've got no problems with that. Yeah, I think either one of those is a contender. I'll measure the consumption now. Yeah, 440. That's actually, that's more, isn't it? I was getting like, what was it? I was getting like 100 and, so, you know, 200 and something. So I think this one's actually more higher consumption. Well, I'm very surprised. The main website, maybe it's an error on the main website, that claims that it claims it's like 180. Wow. Okay. Didn't expect that. Well, I think I'll call it quits there for this video. I got both of these LCD working, which I wanted to do for this part one. So I hope you enjoyed that. Much longer than expected, but I wanted to share with you the whole journey, and that's the point of these project design videos. You know, I could just design it in the background and then suddenly go, oh, here's the finished product, and then do a 15-minute montage of designing and building. But if you like this sort of content, then please give it a big thumbs up and discuss down below and engage and all that sort of stuff, and I can continue this µTimer project, and we'll see what happens. But anyway, I want your thoughts and comments on the LCD selection like this. If you've got a better LCD in mind that's cheaper, better contrast, totally reflective. Oh, I forgot, I did actually put the backlight of the other one on, and yeah, it's exactly as you expect, but it's like 80 milliamps backlight. So I would prefer a 100% reflective LCD, which should give better contrast. But anyway, yeah, we've got these transflective displays. I could hook up, this one's got backlight too, so I could just hook that up there and see what it's like. Oh yeah, all right, give me a second. And boom, there it is. That is a 50 milliamp backlight there. So yeah, 50 milliamps is going to chew a lot from the batteries. I can take it down to, that's 10 milliamps. Even 10 milliamps is useful, I guess. That's the resolution of the power supply I'm using at the moment. I can only go 10, that's 20, 30, 40, 50, and right up to 100. And camera exposure is just going to play silly buggers. So yeah, you know, you might as well, if you are using this LCD, then yeah, might as well like include backlight capability, but you wouldn't use it for normal operation though. But yeah, it certainly does not need the backlight. Turn off the exposure there, and yeah, like you'd make the characters thicker, bolder, you know, to make them look sort of like higher contrast. They're like 2 pixels wide, I think, are they? Anyway, I think either of those LCDs would work, but once again, if you've got a better LCD, please leave it in leave the model number, because you can't include links on your YouTube these days. I think it automatically hides them, but please leave the model number down below. It's got to be like 4 inches. Pure reflective would be nice, and I like 192 by 64. I think that gives a lot of ability to, you know, work with having like, you know, a large timer like this. You know, it'd have at least tens of seconds, possibly hundreds of seconds, and then you can have like multiple timers up there, and then you can have text list modes, and you can do, you know, quite versatile things once you've got that dot matrix screen, of course. Anyway, we'll call that quits for part 1. Let me know what you think. Hope you enjoyed it. Catch you next time.